All right, let's get right into it. We've all heard that warning, right? Stand back from the edge of the platform when a train is coming. But have you ever really stopped to wonder why? What is this invisible force they're all warning us about?
It really is a fascinating question. How on earth can a giant metal box moving past you actually seem to pull you towards it? It sounds like something out of science fiction, but it's very, very real. And let's be clear from the get-go, this is not a myth. It's not some old wives' tale or an overly cautious rule. The danger is absolutely real, and the reason for it is pure, unadulterated physics.
You see these signs everywhere. Stand behind the yellow line. But today, we're going to go beyond the warning and uncover the incredible science that makes those signs so critically important.
Okay, so to figure this out, we have to start with what's happening in the air right around the train. This is really the first piece of the puzzle.
Here's the key thing you've got to understand. A huge object like a train, when it's barreling down the tracks, doesn't just slice cleanly through the air. No way. It actually drags a massive amount of air along with it for the ride.
So picture this. The train is creating what's basically a powerful river of wind that flows right alongside it. And if you're standing on that platform, that powerful current gets squeezed and funneled into that narrow gap right between you and the side of the train.
So, we've got this effect, this crazy current of air. But what's the actual principle that turns a bit of wind into a dangerous, invisible force? Let's unlock this mystery.
The whole secret is in a field of science called fluid dynamics. And yeah, for this to make sense, you have to think of air as a fluid, just like water. The way it moves and how its pressure changes, that's everything.
And this brings us to the absolute star of our show today, Bernoulli's Principle. It's one of the most fundamental rules in physics, and you know what? It's beautifully simple. The faster a fluid is moving, the lower its pressure is. That's it.
This is the one thing to remember. Fast speed means low pressure. This simple little equation explains so many things, from how airplanes fly to, you guessed it, why it's so dangerous to stand near a moving train.
Okay, so now we have our scientific principle. It's time to take it back to the train platform and connect all the dots to solve this puzzle. This lays it out perfectly. In that gap between you and the train, you have high-speed air, which means you have low pressure. But the air behind you, it's just hanging out, relatively still, so it's at normal, much higher pressure. You are literally standing between two completely different pressure zones.
And here's the thing about nature. It hates an imbalance like that. It will always try to even things out. That difference in pressure creates a very real force, and that force always moves from high pressure to low pressure.
So here it is, the big reveal. The train isn't actually pulling you in at all. It's a trick. The normal, calm, higher pressure air behind you is literally pushing you into that low pressure zone created by the train. It's a push, not a pull. Wild, right?
Now you might be thinking, okay, cool, that's a quirky bit of railway physics. But what if I told you this exact same principle is used every single day in a completely different and totally critical environment? Yeah, believe it or not, the same physics that keeps you safe on the platform is what helps keep massive ships afloat and operational. We're going from the train tracks straight into the engine room.
Check this thing out. It's called an educator pump. It's amazing. It has 0 moving parts, but it's incredibly powerful. Ships use these things to pump huge volumes of water, and it all works because of our friend Bernoulli's Principle.
And this is where it all just clicks into place. In the pump, a jet of water shot at high speed creates a low pressure zone that sucks in all the surrounding water. The speeding train, that's the jet. And the person on the platform, that's the fluid being drawn in. It's the same thing! Let's just break it down side by side to make it crystal clear. The speeding train is the driving water jet. The low pressure in the gap between you and the train is the low pressure at the pump's nozzle. And you, the person, you're the fluid that's being pushed in. Same physics, just different parts.
So why does all this matter? I mean, why are we even talking about it? Because understanding a simple principle of physics isn't just some academic exercise. It has real-world consequences that can keep you safe.
It doesn't matter if you're on a train platform or in a ship's engine room, the underlying rules of the universe don't change. It is the same exact physics at work, creating powerful forces we have to respect.
So here's what you really need to take away from this. Fast fluids create low pressure. That's Bernoulli's principle. That pressure difference creates a real physical push, and knowing that simple fact is what helps keep people safe in all sorts of situations.
It all just comes down to one single, elegant principle. That's the beauty of physics, isn't it?
So now you know the secret of that invisible force. The next time you see one of those warning signs, you'll know exactly what's going on. So my question to you is, now that you know what to look for, where else in your world is Bernoulli's principle hiding in plain sight?